So, we've worked some problems going from mole to mole. If you look at this diagram that I have up here, we have a known mole, and then our ratio of unknown to known will give us our unknown mole. But what if we don't have moles? What if it's grams? Because let's face it, we don't have a machine at our lab station that you put some chemical on and it says this many moles. It tells us how many grams. So we need to be able to use gram conversions. And we need to have, let's see, now I want that picture back. That means we're going to need to remember how to change from moles. Okay? For now, we're just going to worry about grams, but we can actually apply this anyway. Okay? If you have a known amount of grams, the first thing you're going to do is divide and change that to the known amount of moles. So you divide by its molar mass. Then we go through the ratio, and then you take that unknown amount that you now have, that's a moles, and change it back to grams. So let's practice. Let's say we have ammonia, the formation of ammonia. What if we have 6 grams of nitrogen to start with? And we want to know how many grams of hydrogen we're going to make. We cannot compare grams, we're not making hydrogen. How many grams of hydrogen we're going to need. We can't compare grams to grams because the masses of nitrogen and hydrogen are so different. We have to change them to moles first. So if we look at our little diagram here, I call this the mole bridge. The first thing you're going to do is change your grams to moles. So we're going to get up on our mole bridge. To do that, remember, you take the mass divided by the molar mass. In nitrogen's case, 28.02 grams in 1 mole. Now we're up on the bridge. I'm going to get this picture. We've changed from grams. We're up on the bridge. Now we multiply by the ratio. Okay? So, what is the ratio? We're going from nitrogen to hydrogen. So we have a 1:3 ratio. As you recall, we put the known amount of the ratio in the bottom. That's going to be 1 mole. And then we put what we're solving for in the top. That's going to be H2. Now we've converted grams to moles, and we've gone from our known moles to our unknown moles. Our final step is to get off of the bridge. In order to do that, we have to change back to grams. If we think about our mole map, to change back to grams, we multiply by the molar mass. Molar mass of hydrogen is 2.016 grams in 1 mole of hydrogen. So, grams cancels, moles cancels, moles of hydrogen cancel, leaving us grams of hydrogen. We just do the math. Six times 3 times 2.016 divided by 28.02, and there you have 1.295 grams. If we follow 1.295 grams, if we follow with our significant figure discussion, we had 2 sig figs to start, so our answer would be 1.3 grams. Next page. On to the next question. This time we're given 6 grams of potassium chlorate. 6 grams of potassium chlorate. honors chem is actually doing a lab with us tomorrow. We want to know how much oxygen is produced. Here's the oxygen. So this is our known. Here's our unknown. Alright, first we have to change mass to grams to moles. To do that, we need to know the molar mass of potassium chlorate. We'll look it up real fast here. KClO3, 122.55. So, how do we go from grams to moles? We divide by 122.55 grams in 1 mole of potassium chlorate. Now we're up on our bridge. So, next step is to multiply by the ratio of the known to the unknown. If we look at our equation, we're going from potassium chlorate to oxygen. Our known amount is 2 moles. That goes on the bottom. We're trying to solve for oxygen, and that ratio is a 2 to 3 ratio. Finally, we want to come back off the bridge, so we have to multiply by the molar mass of oxygen, which is 32 grams in 1 mole. Again, we just do the math. 6 times 3 times 32 divided by 122.55, 2, and we get 2.35 grams. And we had 2 sig digs to begin with, so 2.4 grams. How many grams of hydrogen? Are produced? We start with 3 grams of zinc. We're starting with mass. Divided by its molar mass, zinc has a molar mass of 65.39. Now we're up on our bridge. We multiply by our ratio. We're going from zinc to hydrogen. It's a 1-to-1 ratio. 1 mole of zinc to 1 mole of hydrogen. Now we're over here. We want to go back to mass, so we multiply by 2.016 grams in 1 mole of hydrogen. Hydrogen cancels, moles of zinc cancels, grams of zinc cancels, and we get 3 times 2.016 divided by 65.39, 0.09249 grams. We want 2 significant digits, so 0.0924. That 2 won't round up, so we get 0.092 grams. How many grams of oxygen are necessary to react completely with 4 grams of propane? 4.0 grams of propane, and that is C3H8. Molar mass of propane, (44.10). Grams in 1 mole of propane. Here's our little mole map, or our mole bridge. So we're up on our bridge. Now we multiply by the ratio. The ratio of, and I covered up the equation, we have 1 mole of propane used, and we need 3 oxygens with each 1 mole. So we're going to put 1 mole of propane down here, and 3 moles of oxygen up here. Now we've gone across the bridge, we're ready to come back down. We have to multiply by the molar mass, 32.00 grams in 1 mole of oxygen. 4 times 3 times 32 divided by 44.10. And we get 8.707, which would round to 8.7. Grams of oxygen. Alright, so I'm going to turn you loose on your worksheet. It's on the back of the one you did at the beginning of the hour. Keep in mind it's a block period, so it's on the back of the mole to mole. Now you're going mass to mass. Get those turned in at the end of the hour, whether they are done or not. I need them whether they are finished or not. Okay, thank you very much.